This is going to be part 3 of lesson 2 in your workbook. Lesson 2, part 3 is on page 10. So just make sure you're on the correct page with me. What we are doing for this lesson is we're doing applications of prime factors. So part 1, I taught you GCF. Part 2, I taught you LCM, lowest common multiple. And part 3 is going to be the last application, which is something called perfect squares and perfect cubes. So let's work through class example number 6. So what A says, first it says consider the number 44,100. We could easily do the prime factorization of this guy, and we're going to, right? We're going to break it down and rewrite it as a product of the primes, what we've done pretty much in every lesson. But first what we're going to do is it says use a calculator to find the square root of 44,100. So first of all, your square root symbol is this. So let's write the number underneath our square root sign, which is 44,100. And they want to know what the square root of that number is. Okay, so on my calculator, so take out your graphing calculators, and the square root button, it's right above your x squared button. So you're going to hit the second function, the square root sign, and then type in 44,100. Okay, we're going to get 210. So what I sort of want you to write down is, so the square root of 44,100 is 210. I want you guys to draw yourself a square. And you know that a square from grade 9 has 4 sides. These 4 sides are identical length. And when you take the square root of a number, what you've essentially just found is the length of one of the sides. So this guy's 210 and this guy's 210. And if I said, well, what's the area of this square? You know as well from grade 10 that the area of a square is length times width, or side times side. So the length of this, or the area of this square, would be 210 times 210. And if you go back to your calculator, 210 times 210, is 44,100. So when you take the square root of a number, what it gives you is the area, or sorry, the length of one side of a square. So you need to know that. Okay, now on your test, I am not going to let you actually type in the square root of the number. And I mean, you could to check your answer, but you have to know using prime factorization, okay? So, and it's going to be, and students always do well on these questions. They love these questions. Okay, so we've done this. Explain how we could use prime factorization of that number to calculate the square root of this. Okay, and one other thing I want to tell you guys, if you guys type in the square root of a number and we get a nice whole number here, it's what's called a perfect square. So this is 44,100. It's what is referred to as a perfect square. So for example, like if I say the number 100, is the number 100 a perfect square? If you take the square root of 100 and you get 10, yes, it's a perfect square. 10 times 10 is 100. But let's say I give you a number like 26, and I say, is 26 a perfect square? If you get a decimal, then the answer is no. 26 is not a perfect square. 100 is, 44,100 is. Okay, so how could I get this number 210 without actually using my calculator and taking the square root? So we're going to do what we've always done. We're going to do prime factorization. 44,100, and we're going to divide it by the prime numbers, 2, 3, 5, 7, 11, 13, 17, 19. We are going to rewrite this number as a product of the primes. So we've got a big, huge number. So take out your calculators. I want you guys to do this one with me. So 44,100, let's divide that guy by 2. 22 fifth, 50, 1125. So 2 is 22,050. Divide that guy by 2, and we got 11, what was it? 11025. I know that 2 is not going to work. I'm going to check 3 now. So this number divided by 3, yep, is 3675. Let's check 3 again. 1225. Keep using 3 until 3 no longer works. So now I'm going to go back to 1225 and I'm going to go up to 5. So I get 5 and 245. So 5 and 245. So 3 didn't work. We used 5, 245. And what was it? When I divide that by 5, I get 49. I know that 49 is not divisible by 5. 7 is. And if you divide 49 by 7, you're going to get 7. Okay, so we normally do this, right? 44,100. We write it using prime factorization. So that's 2 times 2 times 3 times 3 times 3 times 5 times 5 times 7 times 7. Okay, so I wrote the prime factorization of 44,100. Now, what it says is it says explain, and you're going to have to do this on the test, on your first quiz. That means I need a sentence. I'm going to write your sentence for you, and you pretty much have to memorize this sentence. So here's what the answer is. If the prime factorization, so if the prime factorization contains of your number, so of 44,100. So if the prime factorization of 44,100 contains factors, and we're going to write the sentence a few times, so you'll have it memorized. So if the prime factorization of 44,100 contains factors that occur, I'm going to write this in a different number because it's important, that occur in pairs, your number is a perfect square. It's a perfect square. Okay, so here's what I mean. Once you write your number and you write the prime factorization of your number, you're going to circle pairs. So my pairs are, I've got a pair of 2s, a pair of 3s, a pair of 5s, and a pair of 7s. If the prime factorization of your number contains factors that occur in pairs, all your numbers pair up, then this number is a perfect square. And watch how we get 210. For every pair, you guys, take out one number. If you multiply on your calculator 2 times 3 times 5 times 7, guess what number is going to come out? So let's check. 2 times 3 times 5 times 7, it's 210. The square root of this number is 210. This guy is a perfect square because all of my prime factors occur in pairs. Okay? Okay, let's do number 7 together. So let's do number 7. And then we're going to write that sentence again. So in each case, use prime factorization to determine if the number is a perfect square. If the number is a perfect square, state the square root of the number. So the first thing we're going to do, because you can use calculators on the test, now you're going to get no marks for doing this. Let's actually take the square root of each number. Let's find which one's a perfect square. So let's take the square root of 1225 and the square root of 3042. So let's actually figure out what the answer is before we even start. So the square root of 1225 is 35. This guy's going to be my perfect square. The side length is 35 for a square, and 35 times 35 times 35 is going to give me 1225. This guy, I'm guessing, is not going to be a perfect square. So 3042, so the square root of 3042, okay, this guy's not a perfect square. So let's erase these square root symbols and let's do the prime factorization of each number. We're going to show this using prime factorization. So I'll do the first one really quick for you. So 1225 is divisible by 5, and you'd get 245. 245 divided by 5 is 49. 49 divided by is not divisible by 5, but it's divisible by 7. So if I write the number 1225 as a product of, or write the prime factorization of that number, so 5 times 5 times 7 times 7, when we're dealing with perfect squares and perfect cubes, you want to, for perfect squares, you're going to circle your number in pairs. I got a pair of 5s and a pair of 7s. If your number, all of the factors occur in pairs, this guy is a perfect square. And so we're going to write that sentence down because you're going to get 2 marks for that sentence on the test, so it needs to be perfect. Remember, for each pair, you take out a number. So 5 times 7 is 35. That is the square root of 1225. So your sentence, you would say this on your test. 1225 is a perfect square. You're not going to write PS. You're going to write perfect square because all of its prime factors occur in what? And the answer is pairs. All of its prime factors occur in pairs. Okay, let's use prime factorization to see, well, why is this not prime? Why is this not a perfect square? And I'll prove it to you using prime factorization. So we're going to take this guy and we're going to divide it by 2, and you'd get 1521. 2 does not work, so jump up to 3, and you'll get 507. 507 is divisible by 3. You get 169. 169 is not divisible by 3, so this is kind of interesting. If I wrote my prime numbers 2, 3, 5, 7, 11, 13, 17. So 169, you would check 5, and it won't work. Check 7, it doesn't work. Check 11, it doesn't work. So sometimes you got to check like quite a few numbers. 169 is divisible by 13, and the answer is 13. Okay, so rewrite whatever number I give you, which in this case is 3042, and write it as the prime factorization of it. Write it as a product of the primes. So 3042 is 2 times 3 times 3 times 13 times 13. Okay, then you got to circle the prime factors in pairs. I got a pair here and a pair here. Not all of my prime factors occur in pairs. If you have a lone number by itself, this is not going to be a perfect square. So on your test, I always give 2 versions, like half the class will write version A, half the class will write version B. Some of you might get a question like A, and your answer will be a perfect square, and we did the sentence. if you're the version that gets, let's say, this question on your test, here's your sentence. 3042 is not a perfect square. Please write that out. Don't shorthand it on your test. Is not a, if you write PS, I'm going to do a -1 for that. Okay, so why is it not a perfect square? Is not a perfect square because not all of its prime factors occur in pairs. So 3042 is not a perfect square because not all of its prime factors. This little guy out here, this 2, does not pair up. It is not going, this 3042 is not a perfect square. Okay, so that's perfect squares. If you guys understand perfect squares, you are going to understand perfect cubes. So before we do perfect cubes, I want to show you how you would take the cube root on your calculator. So for example, if I said, what's the cube root of 27? So you're going to have your square root sign. And I'm going to teach you in a different unit. This is actually called a radical sign. Actually, in this unit, this is called a radical sign. And then we have a 3 here. The index is a 3. So the cube root of 27, if we were to do that on our calculator, what I would get, or where that is, go to your math button. So many things are going to be under your math button, and it's going to be number 4. And then we're going to write 27. So that's 3. Now, because we're dealing with cubes, what we have to draw now is not a square. You have to draw yourself a little cube. Okay? Now, that is the side length of the cube. So this is a 3, and that guy's a 3, and the height's a 3. And in order to get back to when we have a cube, we're no longer dealing with area. We're dealing with what's called volume. And in order to find out the volume of the cube, it's length times width times height. So if I did 3 times 3 times 3, I would get 27. The volume of this cube is 27. Okay? Now, let's do 216. Okay. So if I said, what's the cube root of 216? So on our calculators, let's go to math. Number 4. Let's write 216. I get 6. So if I had a cube, draw yourself a little cube because we're doing perfect cubes now. The side length of this will all be 6. So the volume is length times width times height, 6 times 6 times 6. If you check that on your calculator, you will get 216. Now, let's do this using prime factorization. So I'm only going to do 216 with you, and then we'll do the next page. So let's break down 216, and let's start dividing it by 2. So now we're going to see if this is a perfect cube, and we know it is. But 216 divided by 2 is 108. That guy divided by 2 is 54. 27. Okay. So 2 and 108, 2 and 54, 2 and 27. 2 is not going to work, so let's divide this guy by 3. 27 divided by 3 is 9. And 9 divided by 3 is 3. Let's do the prime factorization of this. Okay. 216 is equal to 2 times 2 times 2 times 3 times 3 times 3. Now, before we do perfect cubes, I actually want to, let's say I gave you this question on a test and I said, is this a perfect square? Is 216 a perfect square? Well, you would have done your prime factorization and then you would have said, pair that guy up, and you would have said no. this is not a perfect square. Do you guys agree? Not all the prime factors occur in pairs. So if I give you 216 on a test, and if I say, is this a perfect square? Your answer is no. It is not a perfect square. Not all of the prime factors occur in pairs. This question asked for a perfect cube. Is it a perfect cube? If we're doing perfect cubes, we don't circle pairs. What do we circle? The answer is triples. And 216 is a perfect cube. Why is it a perfect cube, you guys? Because all prime factors occur in triples. It's a perfect cube. It is not a perfect square, right? This guy is a perfect cube because all prime factors occur in triples. It is not a perfect square because not all prime factors occur in pairs. Flip your page. Okay, we already did 6. Oh, it looks like this is a repeat. We did 7. Okay, let's do number 8. So again, I'm going to give you numbers on your quiz, and it says use prime factorization. It says division table. I will always let you do that one tree diagram I like. And they want to know these two numbers, are they perfect cubes? So they're asking if they're perfect cubes. What am I actually going to ask on the test is I'm going to give you a number and I'm going to say, is your number a perfect square, a perfect cube, or is it neither? Right? Because you got to do the prime factorization. So you guys could, if you want to, break down these numbers like they're huge numbers. I'm going to actually give you, though, the prime factorization. Okay? And then we're just going to look at each number and we're going to figure out if it's a perfect square, perfect cube, or neither. So 6,912, if you break this down, what you will get, 1, 2, 3, 4, 5, 6, 7, there's 8 twos. 2, 3, 4, 5, 6, 7. There's 8 twos. 1, 2, 3, and there's 3 threes. Okay, so if this was your test question and I said, is this a perfect square? Is it a perfect cube? Or is it neither? If you're doing perfect squares, you're going to pair everything up. You're going to circle your pairs. What would you guys think? Is 6912, without actually taking the square root of this, is that a perfect square? The answer is no. Not all prime factors occur in pairs. So that guy's not a perfect square. Okay, let's check if it's a perfect cube. No, it is not a perfect cube. And the reason why it's not a perfect cube, so not a perfect cube, remember you have to write the reason, because not all prime factors occur in triples, right? I got this, that doesn't occur in triples. So this guy, it's neither a perfect square nor is it a perfect cube, okay? Let's do B together. So again, if you want to break down your factor tree, you guys could do that. And then you could compare it with, I'll give you the prime factorization. So I'm just going to write it over here. 970,299. Let's see if this guy is a perfect square, perfect cube, or neither. So if you broke this down, you would get 1, 2, 3, 4, 5, 6 threes. 3, 4, 5, 6. And you would get 3 11s. 1, 2, 3. Okay, let's first check if it's a perfect square. No, not a perfect square. Okay, this guy is not a perfect square. And you would say this is not a perfect square because not all prime factors occur in pairs. Let's see if it's a perfect cube. So perfect cube, you circle triples. Ah. How many of you guys think you're going to take out, if I said, well, what's the cube root of that number? Don't type it in on your calculator. Um, from every group that you circle, you always only ever take out one number. So the cube root of this guy here, and we're going to confirm on our calculator, but the cube root of that huge number without typing it in on a calculator, 3 times 3 is 9. 9 times 11 is 99. Let's confirm that on our calculator. And then let's draw our little cube because I'll want the cube drawn on a test. So math button, number 4, cube root of 970 299 is 99. And again, if I said, well, show me this, like illustrate this for me, you know that the cube root of a number gives you the side length of the number. So each of these sides is 99. 99 units, right? And a cube, we're now dealing with volume, is length times width times height. So it's this guy times this guy times this guy. 99 times 99 times 99. If I double check that, 99 times 99 times 99, what do I get? Ooh, 970,299. And that would be my answer, 970,299. Okay, so I'm going to give you your remaining homework. So your remaining homework is 8 ABC. So flip to question 8, 9, 10 ABD, 12, and 14. Get all that homework done. And then remember, I want you to, in a red pen, mark each question. And your solutions are always at the end of the lesson. So your solutions are going to be on page, what is it? What page is this? Page 16. There's your solutions. I use this to like do quick marking, but if you get something wrong from here, remember to use your solutions on the Google Classroom because this has the complete worked solutions. So if I go to lesson 2, and if I scroll to the homework, here's like all of the worked solutions. So you might want to use this if you need. Okay, and that concludes part 3.